Welcome everyone to episode 3 of Marble Machine 3. Last week, I caused a big controversy. I released this video, Cheap Bearing Housing. 99% of the feedback was, this is such a horrible idea. Please, Martin, stop this madness. In this week's video, I'm making a 3-part follow-up on this controversial design. And in the first part, Lucas from Siegfried's Mechanical Music Museum in Rüdesheim, Germany, is doing a test fit of the actual design because 24/7 Taylor Steel already sent the pieces. It was really fast and we can test this design out in real life. And in the second part of the video, we're having a deep dive discussion about this controversial subject, and I'm using the feedback that you all left on the Reddit page as a starting point for the discussion. And in the last part of the video, I'll show you this brand new design that I made this very morning, inspired by gym machines, a design using pillow blocks, a much more standardized way to do things. So we're going deep into bearing housing discussions this week, and let's start in Germany with Lucas Wendel. Let's open the box. How are you, Lucas?
I'm doing fine. How are you?
Very excited. It's the first part and it's a design that everyone loves.
Not sure about that.
So what are we testing here? These metal discs have holes cut at different positions. So what Lucas is doing is he putting the bearing in and testing if we have a nice press fit. We started with the largest pattern, and as you can see, this is way too big, which I was expecting. So we worked ourselves down, and the smaller the pattern we tried, the better the fit we have.
It's nice fidget spinning you built there, I gotta say.
Here's my whole point with this design that I think almost everyone who has left negative feedback is missing. Laser cut steel plates are not machined. They have not machined precision. So how can we locate a bearing or a flanged bearing housing with high concentricity with a steel plate? Well, the best way to do that is to have a press fit, and at the very smallest tolerance, which Lucas is trying here, he has to hammer the bolts in, and the bearing is super snug in there. At the end of the test, me and Lucas felt like the 2 tightest fits were the 2 good ones. And if I'm going to move forward using this idea, that's the fits I will use. For me personally, I do not think this is the burning dumpster fire that you all think in the comments. I think actually this is a super viable design option. This design is also clamping to the sides of the bearing, which solves perpendicularity. It pushes the laser cut plates into 90 degrees alignment with the shaft. So this design makes a press fit solving for both concentricity and perpendicularity, which I think most of all the negative feedback is completely missing. Honestly, Lucas, now when you feel it, I know you still don't like it, but do you hate it a little bit less?
I'll hate it less once it shows that it can perform, because that's what counts.
Lucas had prepared a surprise for me. He had gotten the kind of flanged bearing housing that everyone in the comments think that I should use for this application. Okay, there we go. There we go. Here it comes.
I mean, this?
Boo! You just want engineers of the world to love you more than they love me, and I think probably you're succeeding now.
They just can come and thank me in the museum during the tour.
Yeah, people should definitely go to Lucas Museum in Rüdesheim. It's the coolest place in the world, for real.
We're going to be at Nerdland Festival next, so that would be the next best option for people to...
Wow, cool. So in Belgium, you can actually go and see both of the original marble machines. So what I've done is that I've started a Reddit page where I can post each and every video, and you all can give feedback on each and every video. And most of all, you all could truly help me out by doing one thing. When you go to the Reddit page and you want to say something about the design, check if someone else already said it. Instead of writing a new post, upvote that person's post. That is going to be extremely helpful, so thanks everyone for writing and visiting the Reddit page. This is the power input module prototype for the Marble Machine 3. The one solution that caused so much controversy and drama is this way to mount a bearing. we're going to go through my main motivation for why I want to experiment with this solution. So the last week's video was titled Cheap Bearing Housing, and that was super misleading, and that's all on me. The price is not at all my main motivation why I want to try this. So the video lacked a lot of context, and it was even misleading. So let's prime the whole discussion with showing these 4 different ways of achieving like a spinning object. The first one here, 2 flanged bearing housings, off-the-shelf parts, standard solution, proven to work, very, very good. Next solution is the completely lathed flywheel. So here we have a perfect running through flywheel, lathed by a machinist with shining metal. It would make a beautiful YouTube video. And we press the bearings in with a press fit and an arbor press. It's perfection. But my friends, it's too much perfection. And here's a big takeaway that I want to share with you. The biggest enemy to a good plan is a perfect plan. So to have a machinist manually lathe this flywheel, it's very, very overkill. Yes, bearing seating would be world class, space grade, but we don't need that for my application. So the real discussion in this video lies between these 2 solutions. If you're not familiar with Reddit, the most wonderful feature it has is that you all, the audience, can help me sort the feedback and put the most valuable feedback at the very top. So you do that by go into Reddit and you read what people write, and then you click the up arrow like this. Boom. I just upvoted Briswolf's feedback here. I'm going to start to read this because Briswolf is really capturing the sentiment. In my opinion, I think you should be using proven traditional designs where possible in your machine. Then you can focus your efforts, including debugging time and extra complexity, on the truly novel parts of your machine. After all, nobody has ever built such a machine to the specs you require before. I completely disagree that the bolt bearing housing has less complexity than a proper machined flange. I suppose it is debatable, but why sacrifice quality so early on in your design process? It is like trying to build a house on bad foundations, in my opinion. Briswolf is really leading with a great example here on how to formulate feedback. It's straight to the point, it's unemotional, and it's been highly upvoted. Thank you, Briswolf, for this. Wholeheartedly agree on this first part. On the second part, I would like to address this. It is like trying to build a house on bad foundations, in my opinion. The way I'm designing this machine is modular. What I'm doing here is I'm welding the steel frame. All the other parts are bolted on. So if this solution doesn't work on, I can head over and use one of these solutions. I've given myself the design space to do some experimentation. And yes, that's expensive. Prototyping, iterating is expensive. But some of that might be actually worth doing in the beginning of a process. But I completely agree with Briswolf that using proven traditional designs where possible is a winning method. If you want this machine to be reliable, please use standard components where necessary that have been proven and can easily be replaced. Yeah, there will be so many problems with this design. I think Martins underestimated the forces a bearing experiences. It may start off all right, but as more stress is put on the bearing as the machine gets built up, it will certainly begin to fail. I don't agree with the certainty. It will certainly begin to fail. Things are not binary. There are nuances to everything. So let's look at the data and let's look at what the bearings are listed for, and let's compare to the forces they will experience in my application. By the way, I am in discussions with SKF, which is a famous Swedish bearing company, to provide feedback on all my designs, and they have given me positive response. They are looking at my flywheel designs. They're application engineers from SKF actually looking at my designs currently. I haven't heard back from them, but I'm asking them for advice as well. Basic dynamic load rating, 16.8 kN, basic static load rating. And then we have 2 RPM numbers. We have reference speed and we have limiting speed. And we can use the lower rating, the limiting speed. Max RPM 19,000. 2,000 RPMs is the max RPM of the flywheel. So the static load, the Wintergatan 3 flywheel weighs 60 kilo at max. So the bearing is listed for 780. Oh, wait, I'm using 2 bearings, so we have to half one of these. 30 kilo is the static load. So as you can see on the static load, the Wintergatan 3 is kind of far from using the listed capabilities of this bearing. There is a little bit of a design space opening up here when the bearing is capable to do so much more than what I'm asking the bearing to do, perhaps. What about dynamic load rating? I asked ChatGPT about dynamic load ratings, and probably that's putting its fuel to the fire. I know I don't have the math abilities to proofread this. 53.57 kilos. Totally admit that I'm over my head here. I can't really proofread this math. My assumption is that physics haven't changed a lot since ChatGPT read the entire internet on physics. I'm gonna go with this number, but I admit this is not really clean. So let's talk about those forces that are going to completely ruin my bearing, definitely. As you can see, I am not asking the bearings to perform at their top performance. I think this image shows there's quite clearly some headroom, some nuance, where there might be acceptable to have a little bit less than perfect bearing housing without critical failure of the bearing. But it is true that these numbers from SKF, depending on the fact that you should mount the bearing in a specific way. So I'm not saying that this proves that my bearing housing works. What I'm saying is that they are sturdy, these bearings. They're not so fragile little snowflakes as I am. You have to take into account kind of how far into the edge of its performance are we really going to push these bearings. Looking at this image, not that far. Robots in Disguise is writing, yes, but how close to the design limits are these bearings going to be operated at? That's my point. We're not talking about an engine here. We're talking about a manually powered machine that will be operated for a few hours a week. In summary, the perfect is the enemy of the good enough, and that is directed at everyone in the comments and Martin himself. Before moving on to the next Reddit feedback, I want to give you a little bit more context of my motivation for even trying this strange unconventional design. I am trying to design, I'm experimenting with how much can I design for one supplier, 24/7 Taylor Steel. 24/7 Taylor Steel is not a sponsor. I just love their service. If someone at 24/7 Taylor Steel want to reach out to me, I would love to collaborate with you, but not a sponsor. So what I'm trying to do is keeping my supplier list short. Basically, for me, they become like a metal 3D printer. I have a 3D printer right here. I can make a CAD design, get it in plastic within an hour. With 24/7 Taylor Steel, I can make a CAD design, get it in metal within a week. So here comes the next type of feedback. Everyone's suggesting me to use a flanged bearing housing. I would definitely be using a flanged bearing to bolt to the flywheel plates. $40 off-the-shelf flanged bearing would save the engineering time trying to chase the tolerances. Would it? Well, let's talk about concentricity. I have the feeling a lot of you who have been thinking that this bearing housing is a done deal, ready-made solution, haven't considered one fact. We have the same tolerance issue regarding to concentricity if we're using this product as if we're using this. So the bearing is concentric with the bearing housing. But how do we make the bearing housing concentric to our laser cut plate? Yeah, you put 4 bolts there and it's concentric. No, it's not. Because these bolt holes are oversized. They're 11.5 millimeter wide, because I think these bearing housings are not actually designed to be used as wheel hubs. I think these bearing housings are much more designed to be used in these kinds of applications. So how would we make this concentric? Well, I would try to put the holes in the plate to one side, and we would have the same exact tolerance issue as we have on my design, relying on 4 bolts. And I would need to test cut the tolerance anyway to get something clamping as correctly as possible to put the bearing housing concentric. Whereas in my design, we're actually relying on 8 points. So we have twice the amount of position adjustment in my design compared to the bearing. This bearing housing is not escaping the issue. It's not solving the issue. Yes, it is holding the bearing in a conventional way. It is not centering my laser cut flywheel. Quick note here, some of these flange bearing housings actually have location pins with H7 tolerances. So we could cut this 4mm hole in our seal plates at the same position and use these location pins. We have the same problem here. Our laser cut is not a machining operation. So we don't have H7 perfect 4mm hole on the laser cut plate side. So this location feature would help, but it's not the perfect solution. Vax and figure right, the real issue you have is the centering of the bearing housing. And homemade or commercial product, that would still be the same problem. I hope I'm not coming off as way too defensive. I am listening and learning from you. I'm so grateful that all of you pros out there are engaging. Martin, please stop this madness and buy a standard housing. This product was my first idea. And I want to mention another thing that got me a little bit worried about these products, because I don't think they're made for this application at all. We have discussed concentricity. Let's discuss perpendicularity. Perpendicularity? I think that's a word. The bearing is mounted in a cast iron housing, which can be bolted to a machine wall or frame. Ball bearing units can accommodate moderate initial misalignment. They are not meant to hold the flywheel perpendicular to an axle, to a shaft. So here's some images of the bearing housing Lucas bought. And as you can see here, the bearing is completely loose inside the bearing housing. So you can actually take it out like this in a specific way. And here's a little video. And actually, this bearing is meant to pivot to allow some displacement of a shaft. So this is an animation from SKF themselves, where they show that these bearings can allow a displacement of the shaft. But this means that the bearings are not at all designed to keep anything perpendicular. So this type of non-stiff flanged bearing housing is obviously the completely wrong idea for this design. And the reason they have designed it like this is to prolong the life of the bearing. This protects the bearing from failure if the shafts get misaligned. So this is a feature, not a bug, but it's only a feature if we're using the bearings the way they are intended. But in my solution, we are clamping to the side of the bearing. The shortest way from transferring perpendicularity from the shaft to our laser cut steel plates are by clamping them to the side of the bearing. These bearing types, they're designed to allow this movement. Part 3 of this video, you are going to like this design. This video is getting a little bit long. You know the famous saying, sorry for the long letter. If I would have had more time, I would have written you a shorter one. It's exactly the same with video editing. Yesterday, I was exercising with Mr. Trainerd from the booming Trainerds YouTube channel. Hannes is putting out fire content every Thursday evening. Check out Trainerds YouTube channel. So when I'm at the gym, I'm always studying how the gym machines are built, because they are sturdy mechanical machines that are meant to work forever, set and forget kind of machines. And of course, they don't have fast spinning objects, but I have been thinking about these pillow blocks that they're using. So this morning, while I was editing this video, I was like, I have to show you this fourth solution. So here we have 2 pillow blocks on the welded steel frame. As we have learned in this video, these bearings are moving in there. They're not moving left and right, but they can pivot. So let's say my welding isn't perfectly aligned. That's no problem for the bearing. The fact that they can pivot saves the bearing. So a big difference is that the shaft will be a live shaft. This shaft will be rotating, and we're clamping the whole flywheel directly to the shaft. So here's my issue with this design, and maybe some of you can help me out in the Reddit. How do I clamp my laser cut plates to this shaft? This is not a machined plate, so we can't use solutions that need machined precision. It's laser cut plates. What kind of flanges can we use to get perpendicularity and concentricity? So I made kind of a little bit of an ambitious flywheel here. So this is an overcomplicated solution. So by using leverage and by offsetting this bolt hole, we can pivot these and clamp the shaft and lock the shaft in place. So that's a pretty creative solution. You will scream, no, there are off-the-shelf flanges. If you find commercial flanges, I would be super happy if you could post them in the Reddit. But think about how to align concentricity with the laser cut plate which has less precision. But to really zoom out and to prove to you that I have been listening, what this solution does is that it's using a proven solution. We do not have to worry about the bearings in this setup at all. These bearings are going to be mounted exactly the way the brilliant engineers at SKF designed them. There's no Martin does smart unconventional shit because he doesn't think like everyone else kind of thing going on. We are safe. And I said so many times during March Next that I wasn't scared enough for risks. I had everything close to its limits and I took chances, and all those chances added up. And in the end, it ended up with a non-working machine. And I think that's why the feedback was so much emotional from you all. You didn't want to see me do that same mistake again. And I'm prepared to think about do like this. So it puts higher requirements on the shaft. The shaft needs to be completely straight. I think completely straight shafts is a thing that the industry have solved. So that's probably solved. However, how do we clamp these plates perpendicular and concentric to this shaft? If you have great ideas, please leave them in Reddit. But I can't get rid of the feeling that you all are really overestimating the risks and underestimating the benefits with my bearing housing earlier. Something I want to do better for the third machine is to use the fact that so many of you are witnessing this process. So I want to thank everyone who go to the official Reddit and write stuff. And especially I want to thank everyone who looks for others' comments and upvoting and downvoting them. In the pinned comment down below and in the description, you will always find a completely new Reddit page for each and every video. And I will try to look back at the Reddit page in the next video every time. So if you have constructive feedback, please go to the Reddit. And if you only want to go to the Reddit to upvote and downvote comments, that is the best help I can get. So thank you everyone for going to the Reddit. You know that I almost named last week's video, If God Designed a Bearing Housing? That would have been such a perfect troll.